Hey guys, we're looking at your CAASPP study guide prep, preparing for state testing with 11th grade. The problems we're going to look at today are focusing on geometry, specifically trigonometric ratios, trig ratios. All right, so again, for these videos, the questions are really weird, like the numbers of them. I pulled them from the CAASPP website for their guest access, their public study guide examples. So these are from the study guide. So while you're working on the study guide, or if you want, different problems, more problems, search CAASPP math study guide questions. You'll click on that first link for the CAASPP website. Follow the instructions on clicking for the guest login. All right. So question, in this case, it was number 6 for my study guide. It says, consider this right triangle, and we want to enter the ratio that's equivalent to the sine of B. So first things first, anytime we're talking about trig ratios, we want to start by writing our acronym SOH CAH TOA. SOH CAH TOA. And this is to help remind us the order of those trig ratios. So we're looking at sine. We're talking about sine. So that's going to be this one here. So what does SO mean from SOH CAH TOA? So this is telling us that the sine of theta of our angle is equal to the opposite side divided by the hypotenuse. So we're going to use that here. So we're looking at specifically the sine of B. So I'm going to start by highlighting angle B. Now from our class, we talk about imagining like we've got a flashlight. So we're in this angle, we're standing in that angle, we've got a flashlight, we're shining that light. Where is it going to hit? So it's going to shine directly across, right? You guys can kind of visualize that. Again, we've got this flashlight shining it from that corner, shining it outwards. We're going to label this. This is going to be the side opposite to this angle B. Because again, we've got that flashlight there, shining it. That's the side that's opposite. We'll always start with, when we're doing trig ratios, by labeling our triangle. The hypotenuse, again, is always directly across from the 90-degree angle hypotenuse. It's also the longest side length, right? Notice 29 is larger than 21 and 20. So hypotenuse is always the longest side and across from the 90-degree angle. And that leaves us with adjacent for the last one. Now, for sine, we don't even have to worry about adjacent, so I'm going to erase it because it's not even relevant for us. So for the sine of B, it's the opposite side, 21, divided by the hypotenuse, 29. And that's it. That's what you would type for your ratio. 21 divided by 29. That's it. SOH CAH TOA. So highly recommend when you see these problems, right? If you got scratch paper, annotate, draw out the little triangle, show that light shining across, label the triangle. What's opposite? What's the adjacent? What's the hypotenuse? Use SOH CAH TOA. From there, what are we trying to find? Okay, we're gonna look at our next problem. Next one is, again, it says question 26, but don't worry about that, ignore that. We've got this triangle and we want to determine whether each expression can be used to find the side length of side RS. Determine whether each expression can be used to find the side length of RS. So our goal is to find RS. So this is our unknown. I'm going to label it as X. This is our unknown. We want to find this value. So you can select yes or no. Okay. So let's see. 35 sine R, 21 tangent. So right now it's looking a little weird. Don't lie. So why are there numbers in front? You might be wondering. So we're still using SOH CAH TOA. SOH CAH TOA. But if you can recall, when we're trying to find a side length, this is going to be using like those, could be the inverse functions, but in this case, it looks like they're not using inverse. inverse functions if we're, trying to find the angle measurement. For that, like this is just normal. We're gonna address these one by one. So let's look at this first one, sine of R. So we've got our flashlight from R. And while we're doing this with R, I'm gonna focus on all the ones looking at R, and we'll circle back to option B with angle T. So I'm gonna label the triangle. This is opposite. Actually, in the spirit of treating this as if it was state testing, you guys will have scratch paper. So let's draw it. Let's get a fresh eyes. So this is R. This is X, what we're trying to find. We've got 35 here and 21. So highlighting the side across, this is opposite. This is our right angle. So this is the hypotenuse. So this side length we're trying to find is the adjacent. So the first one they did was the sine of R. So sine, so the sine of R is opposite over hypotenuse. You might notice our goal here, what they told us is we need to find X, which is the adjacent. And there's not even, X isn't even in there. So this is no, that is not going to help us at all because we are not even including X and we're trying to find that. All right, so let's look at the next one, looking at R again. So cosine. So cosine is adjacent over hypotenuse. So let's write that out. So the cosine of R is equal to the adjacent X over the hypotenuse, 35. If we're getting X by itself, we would multiply both sides by 35. And that's how they got 35 cosine of R. So this one actually, yes, yay! It will give us, we will be able to find what X equals by using that. All right, next one, tangent. So let's check tangent of R is opposite over adjacent. So opposite is 21, adjacent is X. If we're getting X by itself, we'd have to multiply both sides by X. We'd have X times the tangent of R equals 21, but we'd have to get X by itself. So tan R by both sides. We'd have X equals 21 divided by the tangent of R. This one is like, I want it to work because, right, it has all the numbers, but it's not in the right format. It's not 21 times tangent of R. That will not give us X, right? It has to be 21 divided by. So even though it's really tempting to say, yes, it will work because it's the right numbers, the right things, it's not in the right order. So it unfortunately will not help. Or even if they put it as 21 times 1 over tangent R, right? It would still be talking about this, but this one does not work. I'll do an X, so it's consistent here. All right. Now this last one we're going to check, option B, is looking at a new angle. So I'm going to have to redraw a new triangle here. So we're looking at T now. I'm going to add in all the other sides. Again, we are trying to find what X equals. That's our goal. And we're using tangent of T. So this is where our new flashlight is at. So we're going to label this is opposite. This is still hypotenuse. Hypotenuse always stays the same. And now this one is adjacent. All right, so tangent of T is equal to tangent opposite over hypotenuse, TOA. So opposite X over hypotenuse, 35. We want to get X by itself. We're going to multiply both sides by 35. We would get X equals 35 tangent of T, which it works. Yay! All right. So for this one, yeah, this is a bit much. There's a lot is happening in this problem. We're not gonna lie. A lot's going on. But if you see this on your test, I don't want you to panic, even though it looks a little overwhelming. Draw out the separate triangles, just go slow, give yourself, room to breathe, take a deep breath. Center yourself and focus. We got this, right? And just check, does this work, right? Like this last one, it was very close, but just because it had the right numbers, it actually ended up not working. All right, if you guys have any questions, again, please let me know, Canvas inbox. But I hope this helped you, just like as an intro recap for trig ratios, how we use them if and when we see them on our testing. All right, that's it.